Hi, this is Karen O'Brien, and I want to do a video on this debug method. There should already be a video in the Create a Recovery File. The recovery file video is complete and will be uploaded to this page at about the same time as the debug video is uploaded. So when you come here, you should see around in this step 5, somewhere in here, this video. Okay, so we come from documentation.flo-2d.com debug. Now, what you've done already is you have worked through the self-help kit and you've gotten through lessons 1 through 6. And so now we have lesson 6 right here in our QGIS, and we want to debug it. So what we want to start by doing is just to export the project into the debug folder. And that's pretty simple. We just use this export button right here, and we click OK, and then we just go to the debug folder. The project is exported, but this project does have some storm drain data, so we're not quite finished yet. The next step will be to export. So come to the storm drain editor and export the swim file too. So this one goes, QGIS debug folder, and we want to call this swim. That is what FLO-2D wants, just that word, just like that, and click Save. And then this information, I'll just keep default. I don't want to change anything here, and click OK. And then what that has given us is in the debug folder, we have all of the project data files and the 2 storm drain files from this button right here. So this project is ready to run. I don't start by running it in debug mode. I start always after I do finish a lesson or finish something important. I always export the data and run the model just to see that it can run. So you can see here the engine is in the FLO-2D Pro folder and the debug folder is here. Let me just click OK, and that will start the run. And typically I don't care anything about this run other than that it simply progresses through this, through all of the error checks, and you start to see either this screen or you start to see this text screen. Let's let this run for just enough time to get a bit of water into the channel and maybe get that water moving downstream in the channel a little, and then we will close this off. For some reason, there seems to be a bug in the engine right now that if you don't run it and get a little bit of water in your channel, that it's not writing the channel sort for the velocity correctly. So we have to just run. I'm just going to run it a little bit farther, and then I click exit, and hopefully it'll just allow us to write that data because there's enough water in the channel so it doesn't. Yeah, that's fine. And again, we didn't care so much about the data. All we wanted, let's go ahead and let this finish. All we wanted was to make sure that the project ran. And we don't have any temporary files left, and there's not any flow data, so we don't care about the results right now. But we can get from this the error messages for this project and some of the other check files for this project as well. So let's take a quick look at some of these error check files, and see what they say. These all open in Notepad or Notepad++. They're just simple text files. Okay, so this one tells us that there are potential errors in arf.dat. Grid element arf values were adjusted to 1 to eliminate. Okay, basically all this was saying is that they're not really errors. They're just that some of the arfs were a little bit too close to the grid element size. They were like, say, 95% of the cell is blocked, and it's just going to reset those to 100% of the cell is blocked. And then it wrote those elements here. And it also wrote the corrected file right here. So if you wanted to replace your arf.dat with this, you could, but FLO-2D is going to do it for you anyway, so you probably don't need to bother with that because FLO-2D takes care of that. And that way you won't have any instability on those cells that just have a tiny thin slice of surface area. And then there was something else here. The impervious area represented by the R-temp is less than the ARF value for at least one grid cell. The impervious areas assigned to R-temp must include a building area, street, etc. So basically what this is saying is the RTemp and the ARF were slightly different. And so it made an automatic adjustment to reset the RTemp to match the building coverage on a specific cell. And so that new RTemp has been corrected. But you can review them and you can check them and change them. Okay, but typically you don't have to do anything. Now it says there are potential data errors in the chan.dat file, and I know there aren't any errors in the chan.dat file, so I think this might have something to do with it wants you to review your channels to make sure that your hydraulic structures are set up correctly, but there's not any data errors in it. So this message is a little misleading because then it doesn't even give you, what it thinks that it's wrong with it. So this one is just, I would say that you could ignore this error unless there's something following it that tells you, or the model won't run. I think this is just something about the channel configuration with the terminals, the ends, and the channel configuration with the hydraulic structures. Initial abstraction is defined as the interception plus depression storage. So because we have a rainfall and infiltration and a tall, this is just a note to let you know that your initial abstraction should account for the fact that we already have a little bit of initial abstraction assigned to the tall value. So what that means is, if you look at your tall value, let me grab it right here. If you look at your tall value, you will see that the surface detention for this project is 0.01 feet. So your initial abstraction should not include this. So if your initial abstraction was let's say 0.02 feet, then what you would do is you would adjust that to account for the fact that we already have this variable in here, and your initial abstraction needs to subtract this out of it. Okay, that's all that means. And I think the following hydraulic structures have ARF values in the inlet or outlet. I think we can ignore these because the ARFs are not totally blocked, or we can maybe fix them, but we'll see this in our debug process. And then of course you have some storm drain error messages, etc., that you might want to look at from this check, from this particular check. But instead, we'll move on to the debug process because all of this is more covered in project review. And so we'll just ignore it for now. So now that we have run the project and we know that it can run, let's take a look at the debug tool. So if you click Run FLO-2D and you click this guy right here, first thing it's going to do is write a file called QGIS debug.dat, and then it's going to run the debug. So let's set this to date modified and pull it to the top so that we can kind of watch this happen. And we're going to click OK. And hopefully what we'll see is the QGIS debug.dat in here, which I actually didn't see it, so it must have been at the bottom. And then it starts the run, runs it for 1/10 of an hour, and then closes the run. So you can see their temp files are all here. And then once it's finished with the run, it eliminates that QGIS debug.dat file. It deletes it automatically. So yeah, I didn't even get to see it. Yet. Okay, and let's see. That actually what happened just now? I wasn't expecting. So let me see. Yeah, I think I might have done something wrong there. So let me try that again. First, I'm going to delete all these. Make sure we don't have any INP files or INI files in there. We don't. And I'm going to delete these. And I'm going to try that debug run again because I don't think I did that correctly. So let me try that again. And I will, so we want to click on this, run FLO-2D, and then just do the debug run. Yeah, there we go. That's the message I was hoping to see. Now, as soon as you see that, you should, well, let's just give it a quick, let's just tell that message to say okay, and we'll see if we can see the debug file. Lost our, no, it deletes it really quickly. Yeah, there it is, right here. Okay, and then once the run starts and finishes, see, it's done, it's already finished. And it probably gonna get that. The first thing it did was it writes this debug.out file right here. And then I think, if I'm not mistaken, yeah, we'll get this because of that channel bug. But that's okay because we didn't care about any of the results. We just want this test file. The engine ran all these tests for us and wrote this file before it actually started to run. Okay, so we will get, now to load that debug file, we'll use this. Wait, something is, I didn't pull this. Oh, I see. Okay, can you cancel out of there and try that again? We'll click this, and this time we'll just load that debug file from the folder, and you can see it right here, and click open. And it also, so what it does is it creates, not only does it create the debug, but it also creates all these other layers too, which we'll look at in a minute. Okay, so let's take a quick look at this. So we have different kinds of errors and warnings that you can look at. It has the depressed elements, if the channel is greater than if the channel bank is greater than or less than the floodplain bank, and if the storm drain rim is greater than or less than the grid element. So that's the checks that this does for you. So you can use this table to filter this data and to review it. Let's see, wait, I don't think we have any of these. So we have some 800s, we have some 4000s, and we have some 7000s. And in the 7000s, I think in the 4000s, what you'll want to do is you'll want to check the whole list, because sometimes the list changes because the description changes. So the error code kind of picks anything related to a levee or a storm drain, and then the description tells you what's happening. So you can see here that the description changes. See, there is a levee element on a completely blocked element, and then down at the bottom there is a hydraulic structure on a levee element. So 7000 is levee codes. Now, if you click on one of these, it will zoom you to the feature and highlight the cell. So it says this grid cell has a hydraulic structure on a levee. But what it won't do is it won't allow you to come in and make any changes without closing this. So unfortunately, this is not a dockable window. It has to be closed. That's unfortunate. We'll be working on that to fix that this year. But if you do click on it, you can zoom to it, and you can zoom in and out, and then you can review the structure to make sure that it's set up correctly. So let's start with this one. Yep, there is definitely a levee in that cell, but that's okay because the hydraulic structure is on the correct side of the levee. And same thing here. This is a hydraulic structure that goes through this wall, so it's set up correctly. If you have a levee with a WRF, I can't see my WRFs right now, but that's something you might want to check just to make sure that your levee is not on a cell that's completely blocked. Now, if I close this table, I can't get it back. So again, that's something we probably need to work on to be able to get this table back without having to reload the whole thing. So if I wanted to get that back, I'd have to reload it like that. Okay, and so I'm going to close it, and I will show you, let's see. This time I'm going to click down here on the elevation, and I want to turn on the ARFs WRFs. Yeah, there we go. So we can see whether or not some of those cells were okay to be sharing with a WRF or an ARF. I don't have any WRFs in this model, just ARFs. So let's grab that debug table again, and hopefully it'll load this time. Yep, okay. And then let's go to that message number 7, and then we'll just check a couple of these and just see what they look like. So yeah, these ones have a width reduction factor on one side of the levee, but not the other. Now that's pretty much okay. That's not really a data conflict. If the water were to run off of this cell, it means it would be blocked by the levee and it would have to run off in these directions instead of this direction. So I think that's okay. Let's just keep checking a couple of them. So these seem to be okay. These seem to be fine. So let's go ahead and go down the list and check for one that's on a completely blocked. Now this one is probably not okay because this is a completely blocked cell. So the levee will likely just be ignored in this one. It will be like the wall right here doesn't exist. So, but in order to fix it, you would want to come up to your levee lines and just maybe move that levee so that it's over here instead of up on this cell. And that would correct that. So you would just reposition that levee. Let me take the snapping off. Walls are kind of funky about snapping. Like that, and then recalculate those guys right here. But I wouldn't do that until you completely maybe did everything. And then that would kind of sort that out. This one too, like right here, there seems to be a bit of an issue with that one. So same thing, just get that one right there and then just recalculate it, and that would sort that out. So in that debug tool, you want to look now, if you do close that and you don't want to open it back up, you don't want to reload it, you can actually get back to that debug list here with a different kind of table. So if I look at this attribute table, it's a little bit different, but it has the same ability to sort. So it's just a little bit different. So in this case, if I sort by description, you can see that I can get them all kind of together in their own, like there's a levee on a complete, there's like, let's see, 1, 2, 3, 4, 5 of these that I would want to fix. And then the rest of these I would just check. And you can do the same thing. You can just zoom right to them. Hang on a second. Let me, oh, I see. I'm sorry. It's zooming to all of them. I only want to zoom to one of them. So just zoom to it. And you can see that this one, that's the one we were looking at first. And zoom to the next one. And you can see that, yep, that's definitely an issue. Just move that line down here. Try the next one. And zoom to that one. Same thing. This one's probably fine. It's just going to ignore it. But if you want to get rid of the debug message, go ahead and fix it. Otherwise, FLO-2D will just eliminate that levee and it will ignore it. Okay, what else will happen? There's a levee with a WRF. These ones are not usually as critical. It's not a WRF. It's really more an ARF, not a WRF that it's finding. And these ones are not as critical because you can see that that's only partially blocked, so that's okay. That one's okay. Let's just try a couple of these. Yep, same here. There's nothing wrong with these. They're just with an ARF. Yep, and those are all fine. Okay, so let's take a quick look at some of the other errors or the other warnings or errors. And let's see, they were mostly at the top. Let's see, yeah, here we go. Here's a couple. So I already showed you these, but I did want to show you the picture of them. So you can see here that this is the hydraulic structure is right here, and it is on the other side of the wall. And this wall actually might go straight through here. So our hydraulic structure is on this side of the wall, and our inlet and our outlet is over here. So this is okay that it has this conflict with this levee. That's okay. But let's check a couple of the others because maybe there's one that's not okay. Okay, we're going to zoom to that one. And whoops. Oh, there we go. Now this one is not okay because the wall is keeping the water from getting into the structure or to the structure. So this wall is completely in the wrong spot. So what I want to do is take this levy tool, and again, I'm just going to take this editor and I'll just delete that one and move it just over to this side of the cells, and then recalculate that levy or recalculate the wall, and click create the schema layers, and we'll see how this positioning of those levies change. You have that are duplicated, yes, delete the duplicates. Okay, and see how that changed now? And now this is open, and so our water can get down here to this structure. So that's good. All right, let's go ahead and go back to another one, and let's just check the last one. So we'll click on that and zoom to that one, and let's just check and make sure that this one's okay. Can the water get to this? Yes, it can. The water can get down in here, so this one is okay, because the water can just go right down here as it's supposed to. Then that one's okay. So, and then what you can do, what you can do to this is you can edit this, and you can add another row to this table if you want, and let's just call this correction notes. No, let's just call this CORR notes, and then this will be a text, and click OK. Well, the length is 50, and click OK. And then for the correction notes, if we fixed this one, adjusted levy so water can get to structure. And this one, we can say no adjustment needed. And so you can track these and have some notes on what you've already corrected. All right, now let's go to some of these others. Let's go to some of these storm drain inlets and see how we can, if these require correction. So this one has an inlet on a levee. So again, same thing. Storm drain and hydraulic structures act much the same, meaning that they need to be on the right side of the levee. And you can see right here clearly that this one is on the wrong side of the structure. So for this one, we don't move this hydraulic structure, because the hydraulic structure comes from those shape files. So on this one, we make our corrections from the shape files. So let me show you what I mean. I'm going to go back here to my data and grab the lesson 3 data, because the lesson 3 has our shape files. So we have these 3 shape files, and I want to just click this layer right here and then go back to that folder and then grab my shape files and bring them in here. So yeah, you can see right here that this this wall, because this is a 30 by 30 grid, this wall is kind of a little bit on the wrong side of this levee. So either I can put my inlet, here in this cell. Let me just ID that cell. I can put my inlet in this cell, or I can move my wall to this side of the grid. Let's try the wall. Let's try to move the wall first. And if you had a 20 by 20, this would not be really that big of a deal, but we don't. So let's try to move the wall first. So if I go my levee line, or you can do it in your walls, whatever you want. You can do it in your source data, or you can do it here. Either way, you have to recalculate. And use the vertex tool, and then I'll just grab this and move it over to the side a little bit. Let me just move this one a tiny little bit too. And then again, recalculate your levies, and it would move that wall. But recalculating levies on a large project can be cumbersome and time consuming. So you want to really be careful and not do that, do all your changes and then do the recalculation. And now you see that that inlet would be on the correct side of the levee. It can still get into the channel and flow. Or, like I said, we can move this point right here from here. So in this case, we'll need to move the point. So edit, vertex tool, and we need to move the conduit. So we'll start with the point. We'll just move the point here and then move to the shift to the conduit. And now I do want my snapping tool because I want my conduit to snap straight to that node, and then click save. And then I would need to recalculate my storm drain to move that inlet away from that location and get it on the correct side of the wall. So you can do it either way. Let's take a look at another couple of these. I'm just off on that table that there's another inlet on a levee element, and we'll just zoom to it and see if this one's okay. Yeah, this one's fine. Wouldn't need to do anything with this one. Let's go ahead and go to the next one. This one, see, this one is okay, but honestly, it might be better served if this inlet was in this cell, because this inlet is clearly up on a higher elevation. It's probably not going to get much inflow. So this one, we're not moving it because it's configured incorrectly, but we're just moving it because this cell would do a better job to get water to the inlet. So edit and node, and we just move it over here. And then conduit, same thing, you have to move the conduit too, and then move the conduit as well. And then you would save those two layers, and then when you're ready, you'll have to recalculate your storm drain. Okay, let's go ahead and go to another one. I'm just zooming to them from the table again. It's just clicking on the row and using the zoom to feature button. And then I just move that off screen so I don't need to look at it. Okay, so the next one is, let's take a look. Kind of same issue. This one might be better served over here. So something to consider, but the configuration is okay. It's not a problem with the configuration. Let's go ahead and move to the next one. Yeah, there's nothing wrong with that one. It's perfectly fine. And this one's good too. You can see it's right. It's exactly where it's supposed to be. And this one is interesting because it's right on the sidewalk. So I wonder, is this grate up here, or is it a curb and gutter that should be like right here? So that one's kind of a hard to say on that one, whether or not we'd need to fix it. Let's say, well, clearly it's in the wrong spot. It's clearly being picked up on the wrong cell. So I would say on this one, the thing to do to fix this one would be, I don't know, I just leave these on edit just to change that down a little bit, and then grab the junction and move the junction down a little bit too. Just move it down a little bit, get it on the cell and away from that levee. And then we can check the next one. And this one, now this was an interesting one because in this case, I think the grate or the inlet is actually like right along the end of this cul-de-sac. And and the funny thing is, when you see something like this, you might see an inlet here, and then you would see another inlet here, and then it would connect to the system. So in this case, I don't see an inlet along this curb, so I think our inlet is right here. So this means that our levee is in the wrong spot. So in this case, we would take our levee, and again, I'm either going to use the levee line editor or I'm going to use this source data for the walls. In this case, I can just use the levee line editor, and I just want my levee to be along the bottom side of this grid element. Let's just see what that does. Sometimes you don't need to like save the changes, it'll do it for you. And see there, and now our inlet is here on this cell, and it feeding into this one, so we don't need to make any changes to this one. It's perfectly fine. Okay, so that one is okay. Now let's inlet on a levee. We have 2 more. Now this one is interesting because same thing, except this one, not only does it have the inlet here that's on this side of the levee, but it also has an inlet here, and there's also a levee in this one. So now this is interesting because this one needs to be on this side of the levee, and this one's kind of just in the wrong spot. It needs to be on this side of the levee. So this one's just a little bit funny. Let's, again, we're gonna just come in here, grab our levee tool. And this time we want, actually this one this one's a little bit hard to kind of decide which one to make the adjustment on. Whoops. But I'm gonna take out a little bit of that curve. And I'm gonna take that one out and just move that up there. Yeah, and then that should reposition this levee up here. But then I'm gonna take this inlet and I'm gonna move this inlet up here a little and move that conduit up here a little. And then I would recalculate both the levee and the storm drain, and so that those are positioned correctly. And then one more inlet on a levee. Oh, it was this one. So then we fixed the last 2 here. Okay, levee on a completely blocked cell. That was the next description as these, and we've kind of already seen those. Now, again, like I said, FLO-2D will correct these for you. And this one's just adjacent to a completely blocked cell, so it's fine. But FLO-2D will correct these for you, or you can correct them so that you no longer receive the message. So let's go to the next one. That one's okay. This one is not okay, so let's go ahead and just take our levee lines and just move them. Yeah, this one's actually not really correct at all. There. Yeah, then this one will go block, 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 and then this block will pick up down here. Yeah, block will pick this one up. This one will go this way, and this way, and those 2 will fit right together and get off of this one. Let's see, we just want to make sure that it's off of this building. And zoom to the next one, same thing. This is a totally blocked building, so this is an easy one. We'll just put it right here, and that'll take care of that one. Whoops, I don't know what I just did there. Actually, we can put that right on its wall. It's kind of off a little bit. Okay, yeah, and then there's an opening right there, and it picks it back up. Okay, so that one will be ready to correct when we recalculate the levee. That will fix that one. Let's go to the next one. And this one, same thing. Yep, this one's a little bit harder. So let's just bring that up where it's supposed to go. And let's see. The totally blocked cell is here. So let's just get that kind of off that. Let's put it in the other cell. You know what? Turn off the snapping. Okay. And that should make sure that that levee is calculated in this block of cells instead of this block of cells. And that one will be fixed when we run the calculator. And the last one, and the last one was right here. So that fixed both of those 2. So now if we click the levee calculator, that saved it. And I'll just click to create the layers, and that will reposition those and delete the duplicates. So you can see now that those are correct now. And all those others are fixed too that we had made adjustments to. Okay, if there's a levee with a WRF, there's a bunch of these. I would say just check them, make sure that they're kind of configured correctly. But typically it's just a partially blocked cell, so it's okay. And that is pretty much it for this particular project. Now you'll get other notes. And when you get your other notes, so I'm going to save this, or no, I guess I already saved it. I'm going to close it. And then we would save these guys. And then go back to lesson 3 and reprocess the storm drain from the lesson 3 data. And then in addition to the debug, we also have some depressed cells, channel bank elements, and floodplain rim differences. Let's take a quick look at these guys. So depressed cells are, in this case, the depressed cells are easy because I already fixed all the depressed cells, but there are some in here. So I'll open the attribute table and we'll zoom to these. And you'll see that they're inside the channel. So the channel takes care of these. The channel corrects these. So you can just ignore them. And I know that all of them are inside the channel. So I'll just show you one more. And depressed cell means that all of its neighbors are more than 3 feet higher than itself. That's what, because we put our depressed cell calculator as 3 feet. So that's why we got those. And the model will just ignore those because they are not even part of the computation anymore because the channel has replaced them. Now, what about channel bank differences? This one is a little more, so this one I really do actually like to use this editor instead of the other editor to look at these for 2 reasons. One, you can sort this table from high to low, and then you can focus on the ones that are greater than like 5 feet. In this case, I take greater than 5 feet. So if I hit edit, and then I get all of these that are, outside of the range of 5 feet, I can just delete them. And then that reduces the number of cells that I need to look at. See here? Now let's start with the worst. The difference is 11 feet, and we'll just start there and work our way through these. So I'm going to select this group, and then I will zoom to that feature. And I will actually also think I want to make those like either a super bright color or something, just so that we can kind of see them better, or just turn these others off. Now let's just turn these others off for now. Okay, there. And now you can see here that I have, let's see. Let's do this. First of all, let's take this off and let's turn off the, let's turn off these 3 layers just so we can clean the map up a little bit so that we're only seeing this. And then maybe let's do this. I'm going to change the symbology of our elevation map to hillshade so you can kind of get an idea, a better feel for where this water or where these channel cells are in relationship to the channel and why there's a change in elevation. So what we have here is a channel that, or a bank that kind of, because of the 30-foot cell size, our channel alignment is sometimes out on the bank and sometimes in the channel. Now, as long as the channel width and is accurate, it's okay if these aren't perfectly aligned, because what FLO-2D does is when it runs, it will take this grid element and it will bring it up to the bank elevation. Now, in this case, I don't really like the position of this one, so I might reposition this just to get it in a better spot, like right here. So on this one, the fix could be to just ignore it and let the model, make the correction in the bank data, or you can reposition it with the schema layers. So if I hit the edit button, let me grab these guys right quick, edit, and I will maybe also need to edit the cross section. So I'll just edit them both, and then I'll set this to all layers. And then I'll take a vertice and just put a vertice right here. So I'm just going to click and then click again. And now I have a vertice right here. And now when I go to schematize my channel, which is up here, you'll see that it'll reposition it. And of course, then once you repositioned it, then you wouldn't get that 11-foot difference anymore because it would be up here better on the bank. And you can do the same thing on the right-hand side as well. The right-hand side works exact same way. So if I have it edited and I come in here and I want to like reposition this one, again, I can just pick up the node tool and add a vertice right there. And then when I go to schematize this, it'll just move that bank slightly up. And then if you don't really like the position of it, you can just do this instead. You can just move the cross section slightly up, and then it would get rid of that other right bank. See? And that kind of just looks a little bit better. I don't particularly like that one, so I would do this. And then you have, so that's one way to correct if you don't like the position of that. And then we can just go on to the next one. So the next one, there's another one that's 11-foot difference, and zoom to it. And same thing. It's the exact same thing. Our channel is down here. Maybe we want it right here, or maybe we don't care. But let's just move it. Just see how simple, just so that you can see how simple it is to move it. And there you go. And this one's off a little bit too, but that one's okay because we're focusing more on the ones that might actually be problematic. This one we've already fixed. And this is a left bank, and it is off by 10 feet. And that must be this one right here. You may be able to flash these too. There used to be a tool in here where you could flash it, but I think maybe it's not in this editor. Yeah, it's just it is this one because it's the bright colored one. Or no, wait, actually it would be the one right in the middle. Sorry, it's going to be the one right in the middle of your screen. Unfortunately, the color of those is just really close to the color of, let's just make these pink. And that way the one we're on will be yellow and the rest will be pink. And then I need to also turn off maybe these guys. Yeah, I need to turn off the outfalls as well. Those were also yellow. So that was kind of making it difficult. Okay, so now the pink ones are our bank to be corrected, and the others are, the yellow ones will be the bank we're looking at. So same thing here. And like I said, you don't have to fix all of these because FLO-2D, like in this one, FLO-2D will fix it. So if you want to reposition them, that's fine, but only reposition them if you have like some flooding along the edges of this channel right here that looks a little bit weird. It's causing you to have really deep depths, like right along these houses, because the channel is shifted a little bit too far into the channel. So the channel alignment on this one is pretty good. And you can just ignore most of these, and like I said, you can even add a cell, add your notes, a new field, notes, or let's say debug notes, and then change that to text 50, and then just put in here what you did to fix it. Let's go here, difference, and repositioned the bank, and then save it. And then the last one I wanted to show you is the floodplain rim elevations. So same thing. Again, like if it's only 0.0 something feet, which most of these are because I used the grid element to set the rim elevation on most of these, but I did that a really long time ago. So as things kind of shift and things do change. So I would say if there's anything in here that we wanted to look at, let's just go to the most extreme ones and use the zoom feature, the zoom tool. And yeah, that one is definitely, you're going to want to fix this one. So how would we do that? It says that the rim elevation is, well, look, it says that the floodplain elevation is 1420.3, and it says that the rim elevation is 1418.7. And so the rim is much lower, and so FLO-2D automatically adjusts the grid element to the new floodplain elevation right here. Now that one is fine, but if there was an adjacent cell that was blocking water from getting to that cell, that's where you would want to make a correction. So this one is fine because FLO-2D fixed it for you. But if you did want to correct that, you could use the correction tools for the elevation and get that elevation down to what closer to what you want. And so I'm going to go over just one more of these just to show you one more. So we'll zoom to that one. Now this one is a foot difference. The floodplain elevation is a foot higher than the rim elevation, and it is right along a gutter. So that's not surprising because when you're right along a gutter, let's turn our storm drains back on real quick. Oh, it's hiding it. These are terrible colors. It's hiding my storm drains. Okay, so you can see that that this cell is a little bit higher than the inlet. Now this is just a grate right here. That's just the inline grate right here. And that this one is just a little bit higher than it, or could be a manhole. And so then again, FLO-2D made the correction and brought it down a little bit. And if you don't like that, if you're not okay with that, then you can make the actual correction either to the grid element or to the rim elevation of the feature, of the inlet feature. You can make the correction either way. So if you wanted to correct the elevation of the feature, if you look at your inlet tool here, you have an invert elevation and a maximum depth. So if you want to make a change to the rim elevation, you'll increase or decrease the maximum depth of that feature. Or you can use the rim elevation. You can call this rim elevation and sample this rim elevation straight off the grid. And then the ones that you want to adjust to the grid element elevation, you can just sample that and calculate the rim minus the invert would equal the maximum depth. And you could fix it that way as well. But that's all part of the advanced storm drain class, so don't bother with that for this class. Okay, now there are two more things that this table does. So first of all, let me turn off my editors on all these. Whoops, wrong one. Sorry about that. And on this one, since we did make adjustments to the channel, you would want to go back into your channel lesson. And so once you hit this tool here, then you're going to need to hit this tool or this tool and just redo your interpolations. So again, that's all part of lesson 2 or the advanced channel lesson. We'll show you how to redo those. And again, recalculate the storm drain so that it'd be select these guys from the shape files, reset up your shape file, reset up all your tables, assign the storm drains, assign your tables, hit your schema button, and then export your swim all in lesson 3. So let's just turn those editors off. Okay, and I'm going to turn those off as well. And this button also will do 2 other things. It will run a levee test for you to test and make sure that all of your levees are above ground. And that's what it's doing right now. Or it will do a conflict resolution table on the whole project. So again, I don't go from this table because it locks the map and there's no sorting or anything like that. So instead I close that down and then I go to the conflicts, and I'm just going to pop those down with my debug conflicts. And because this all kind of goes together, I go to these conflicts. Oops, sorry. And I do my inspections from here. So let's see what we got here. So we have the crest elevation and the cell elevation and the opposing cell elevation. So what that means is, let's zoom to one. Okay. Where is that feature? It must be like right here. Okay, here we go. Sorry, I just needed to get that to turn that color, because there's more than one. That's why I couldn't see it, because this cell has more than one levee. So what you see here is that our wall is 1413 and our cell is 1406 and our adjacent cell is 1407. So that means that this feature right here is 1413. This cell is 14. Let me show. Let's get the ID tool. This cell is 1406 and this cell is 1406.9. This cell is 1406.5 for this levee. So let's see if that's what this says. Yeah. So this is fail direction 6, or wait, we want fail direction 3. This is fail direction 3 of this cell. Fail direction 3 is south. And so this is 1406.5 is the grid elevation, and the grid elevation to the south is 1406.9, and the crest elevation is 1413. So there's nothing wrong with this one. So one of the things that you can do is you can put some difference calculators in here. They should probably already be in here. If we go to add a field, and I'll just do this, I'll just put this into the code because these difference fields should already be in here. So cell difference, and that is a real number. And then we'll need another one that is opposite cell difference. And this one again has to be a decimal. And then what I can do here is I can take for this column, set that to cell difference, and I can put in here that this one will be the crest elevation, that's your levee, minus the cell elevation. Oh, I guess I'm gonna have to do it from here. So let's try that again. So this one will be fields. This will be the crest elevation minus the cell elevation. And I click OK. And make sure that's in the right one and update all. And then this one will be the crest elevation minus the opposite elevation. So let's just change that here. And that's OPPOSCEL. Yep, that'll work. And update all. Yeah, opposite cell difference, update all. Cell crest elevation. Okay, hang on, something didn't work. Oh, you know what? I took the cell, not the elevation. Sorry about that. Okay, and there we go. So now what do we want to see on these? We don't want to see any negative values, okay? So you can see even this one, that this particular levee is only 0.1 feet higher than its grid element. So it's not doing any good. It's not doing anything. So if you zoom to it, you can see, yeah, this wall is clearly like, you know, a standard 8-foot wall. You could even get into your street view for this one and see how high that wall was and see that there's something wrong with this wall. So let me just do that real quick. Well, hang on, I'm gonna pause the video, then I'll do that. Okay, so I found this location on the Google map. So this is 16th and Bell Road. So we come to the Google map. We should be able to see that location. And you can actually even bring those points into your Google map. but I'm pretty sure that that's along this neighborhood right here. So let's just double check that. So we'll make sure that this gas station is here. Yeah, or oh, I guess it's not a gas station, it's something else. And then let's just get an idea of where this is, like in the middle of the block. I wish, okay, here this one is to move the map to the location. I just hit this guy right here to move the map to the center of the map. There, I know there's a flash in here somewhere, but I think it's in the filter. And of course, there's more than one cell. So maybe we have to get the last one. Yeah, there we go. Okay, now we can see it. So it's about at the middle of the, about right there. So let's 1, 2. Okay, let's see this. So that's 1, 2. So it's about right here. And just go see what that wall looks like. Okay, so that wall does change in here, but that's a pretty clear that that wall is not a foot in elevation difference. So we can make sure that we correct that and at least get that wall at least 3 feet of elevation higher than, you know, right here it's like 3 to 4 feet higher than the cell, and then everywhere else it's, you know, 6 to yeah, around, it looks like around 6 feet higher than the cell. So how would you fix that? You come into your cell and you grab the elevation of this line and you just make an adjustment to the elevation of the line right here. So if I select, sorry, not there. If I select that levee line and I select the feature, I can, if I edit the, open the attribute table and then move the selected feature to the top, I can grab that and just make an adjustment to that. So 1418, let's just say 1421 or something, or 14, you know, whatever that is, +3. Just give it, it just needs to be the bare, it just needs to be able to block water. It doesn't have to, it's not going to be overtopped. Nothing like that's going to happen. So the exact elevation is not important, just so that it can block the water. And then recalculate. And now that I've made an adjustment here, recalculate the levees and move on. And that's how you use this tool. And it's actually really handy. And you see that there's a lot of them in here that have that problem. And you can color them. So if there's ones that you don't care about, let's do a difference. Yeah, so like here's some more that are a little bit weird. You know, we don't have 30-foot walls in this project. So that's another one that could have an adjustment on it. But let's just take anything like less than a foot. Yeah, we'll take anything less than 1 foot and we'll just eliminate everything else for now. So again, anything less than 1 foot and just delete it. And then make it bright colors and make it bigger. So levee crest conflicts, I like to make them a super bright color. So we could go bright green, and then we could change the shape of the marker and take off the solid line and then change the shape of the marker to a square and make the size 30 map units and then click apply. And now you see that these would be really easy to see and to correct. Really easy to see and correct because we made them pop. Okay, so that's that. Now there's one more thing that this tool does, and it is to do if you use the current project, you can do a conflict table, and this will give you basically the same thing from the debug table, but maybe a little bit more detail. And you can, again, click on it and it will take you right to it, and you can just look at them and see, you know, if something's wrong with these, or if I need to make a quick fix on these. Same thing, 2 or more levees in the same cell. Well, of course there's going to be 2 or more levees in the same cell, so that's kind of a dumb one. And then let's see what we got. Inflows, inflow on a left bank in the same cell. Yeah, well, we want that to happen because that goes into our channel, so that one's okay. Outflows, outflow and a left bank on the same cell. Again, that's the way we set that up, so that one's okay. Hydraulic structures, we've already looked at those. And let's see what levees just picks up all those reduction factors and things. Storm drain inlets gives us those storm drain inlets. Oh, this one's might be important, more than 2 inlets in the same cell, but it's probably not. It's probably an inlet and a, it's probably an inlet and something else, an inlet and a junction, so that's okay. It's not 2 inlets, it's an inlet and a junction. So you don't want more than 2 inlets on the same cell, but it's okay to have an inlet and a junction on the same cell. Okay, and that is basically it. That is pretty much the debug tool. And so I will pause up the video and post it to the documentation so you can try these out from the documentation and you can try out the advanced lessons.